We'll be ready to go. And a participant has enabled closed captioning. Ooh, that's good. I, again, don't know how. Whoops, it's recording me being a goof nut. All right. Can you cut the front off the recordings? Ooh, we're at my timepiece says 12:59, as if my timepiece is not a phone. Oh. So anybody have any exciting battery stories? I like to start with, oh, somebody gave me, oh, Jesus. Oops. Somebody gave me a good intro question. Oh, it was about discharging batteries. If you discharge a battery below 30%, you can ship it without all of the DOT requirements tagged on. There might be some, but it's theoretically less. I don't see anybody doing that for the volume of the little batteries we get in, but we're sure running into problems with those high energy batteries and how to manage those. And maybe that's an option. I don't know. Anyway, that was my thought of the day. I haven't seen online any battery dischargers, darn it, that that I would feel comfortable with. They're kind of designed for little stuff. You guys can have thoughts on that. Otherwise, I have to tell another story. Welcome if you're just joining us. We're waiting for people to get online, get into the session. We'll start in a minute or two. Thanks for being here today.
Jennifer, back to your comment, it's my understanding that most of the big equipment is still over in Europe, that it hasn't come to US because we're quite a ways behind the curve when it comes to recycling EV batteries and other higher charged batteries. So they're just now starting. I've got two here in Michigan that are looking at putting in discharging stations.
To HHW facilities or?
No, these are private industry.
Yeah, that's what I thought. I think, yeah, like you said, it's going to be a while. That was my assessment as well. All righty, folks. One more minute left. We've got, 119 participants in, 120. Keep going. I want 180, just kidding. All righty, well, we've got 120 participants signed in so far. So we'll go ahead and get started with a couple of introductory slides. NAMA is hosting this webinar series. We worked a little bit with EPA, and then we ended up working with a lot of our contacts in Region 5 to get these set up. We have, in fact, today's moderator, Rachel, you're from Missouri?
Yes, please.
Missouri. Sorry. All right, we'll go ahead. And again, NAMA is an excellent professional association. I've been a member since 1995, and it has just proven invaluable to me in my the work that I do. I apologize, I have a super sensitive mouse and I should not be using it. The other thing I wanted to bring up again was that we have a special offer for attendees. If you'd like to join NAMA, if you like what you're seeing here, we'll give you a discount on that. And there's a link there for who you would contact, and this slide will be it will be in the presentation, so you can take a look at that if you need to see it again. It's also on our website. And I like to do a little bit of advertising for our national conferences. These, you get a lot of value, a lot of networking in, they're excellent. I highly recommend you attend. If you're a member, you almost save, at least you used to, the price of a membership is how much we reduced the conference cost. So it's worth it for that as well. And I think this is where I turn it over to Rachel. Just so as you know, I've been trying to add the logos from the different companies here, and I'm running out of space for the contributors to this series. So thank you, everybody, once again. And Rachel, I'm going to mute myself.
All right. Thank you, Jennifer.
Welcome.
And thanks for all your coordination on this webinar. I would also like to thank Amanda, who is the EWIS coordinator for Minnesota, and Steve Noble for helping to put this together. Thank you guys. You guys have been amazing. Now, we've had some interesting webinars earlier, and you can see here on the screen, one is how to safely collect batteries, DOT regulations and consumer education. There was another one on lithium chemistry and safety, recycling and regulatory framework, and electronics recyclers and battery container device management. I mean, I have listened to those webinars over and over again. They've really been amazing. We encourage you to go onto them as well. Jennifer, do you want to? Okay. Now we have the next webinar coming up on February 28 on extended producer responsibility for lithium batteries at 1 p.m. You can also register for that on NAMA's website. And for today, we will be having a webinar on EV batteries. Jennifer, you want to slide on to the last one, please? Yes, state of practice of EV batteries. Now we have 3 seasoned, amazing speakers, and I'm just waiting to really hear what they have to say. They have so much knowledge. We're going to start with Jerry from the Institute of Scrap Recycling Industries. Jerry is a Senior Director of Safety at the Institute of Scrap Recycling Industries. He has over 30 years of experience in the environmental, health, and safety and transportation industries. Now, our second speaker today is Shane Thompson from Cerber Solutions. Shane has an impressive 20-year career in battery lifecycle management. These experience includes leadership in environmental sales, commercial operations, and process development. He currently serves as the EVP of Business Development and Strategy at Cerber Solutions. Now, our last speaker for the day is Mark. Mark is the president of Umicore USA. He graduated from Brussels University in 1983 with a chemical engineering degree. Umicore is a leading circular materials technology company with an extensive expertise in the fields of materials, science, chemistry, and metallurgy. We really appreciate our speakers for today because they've worked so hard in putting this together. Also, if you have questions, feel free to use the Q&A function. Now we will take questions after the presentations. If we have some extra time, maybe we could pop in 1 or 2 questions after each presentation. Steve Noble will be monitoring the Q&A sessions for us today. Jerry, if you're ready, please, you can start your presentation. And thank you all for joining us again. Enjoy.
Thank you, and good afternoon, everybody. First, I'd like to just introduce ISRI. ISRI is the voice of the recycling industry. We represent both ferrous and non-ferrous processors, auto recyclers, paper, plastic, glass recyclers, rubber and tires, electronics, and many others in our industry. We truly are the voice of the recycling industry, and we're recognized around the world. I'm pleased to be here and share with you all. Batteries of all sizes threaten our industry, all the way down to even button cell size batteries. We're seeing losses across the country and further out around the world from fires resulting in millions of dollars and they continue to be a real issue for us. Obviously today I'm going to be talking about electric vehicle batteries, something that we're just starting to get into as the technology changes, as the market grows. We anticipate that we're going to be seeing many battery or vehicles, electric vehicles and hybrid vehicles coming to our recycling facilities as the market continues to grow. And we recognize that so far there has been very little information about these vehicles. And as I said, we continue to learn. We are developing programs working with other parties and looking at many potential hazards associated with these vehicles. Some of those hazards are electrocution hazard, where we're seeing vehicles over 800 volts. We're looking at fire hazards. We're looking at explosion and thermal runaway hazards with these batteries. And we're also looking at the potential for off-gassing, hydrogen fluoride being one of the most potentially serious gases that some of these batteries can give off. We're also looking at an arc flash potential. For those of you who may not know, arc flash is when something shorts out and you end up with an explosion that's hot enough to melt metal and contains a blast that can injure the person working around these pieces of equipment. One of our biggest threats are compromised vehicles. Having a vehicle coming into our facilities intact is one thing, but having vehicles that have been involved in a crash creates a real serious concern for us. A lot of the issue with compromised vehicle is thermal runaway. And basically it results in cellular failure, which causes the thermal runaway and then results in propagation and can cause some serious fires for us and damage other areas around our facilities. So we have to be very aware of that. The other part is flooded vehicles. We're seeing a lot of that from the hurricanes in Florida. Those vehicles are compromised and have a potential for shorting out and also causing cell failure and thermal runaway. One thing we've recognized, and there's a new term that we're hearing about, which is concussive battery. And much like the cell failure from having a crash, it could be a minor crash where it looks like there isn't a whole lot of damage to the vehicle. However, much like a human concussion where the brain hits the skull, battery cells can hit each other and may not have apparent damage. But there are cases where because of concussive battery, fires erupt 30 days later or even a month and a half later. And that concerns us a lot. So we're really watching those types of things with these batteries. So even undamaged vehicles have a potential to be a problem for us. And we need to make sure we're looking at vehicles that are being coming to our facilities. They may seem like they can't operate. Anything like an appliance or a vehicle may not have enough charge to function. However, we recognize that some of these batteries still may contain 80% charge to them or more. Part of the other issue we have is towing or dragging vehicles, because in many cases, these vehicles can actually create a charge that feeds back into the battery. And we need to be very well aware of that as we're going through this. So what are we doing? We're developing training programs for our industry. And right now we're at the point where we're looking at 3 levels of training: awareness or inspection level, technician, and advanced trainer. The awareness level, we're actually currently working on curriculum, and we're going to be filming a session that's about an hour long, which is going to be web-based training. And we're hoping to start filming the end of February, the beginning of March, and we will release that to our members where they will actually be able to sit through and take that program, and they'll get a certificate of completion from that, and we'll know that they went to that. To move to the technician level, we're putting curriculum together for that. That's actually going to be a hands-on program where you need to pass the awareness level in order to advance to the technician level. And we will be teaching technicians how to safely work around those vehicles. And I'll talk a little bit more about that in a couple of minutes. The awareness level, I just wanted to point out, we will be teaching people to be able to differentiate between hybrid vehicles, full electric vehicles, and other vehicles, and also differentiate between compromised vehicles and not, and where to actually place those at facilities to keep the compromised vehicles away from everything else in case there is an issue with it, to prevent fires that take off and cause a huge problem for us. The technician level, again, is going to be in person, as well as the advanced. After you take the technician level, our advanced level is going to be more for the management people and actually create them to be a train the trainer. We're hoping that this program will take off and allow these people to show others how to work around these. Some of the things that we're going to be teaching about the fires and other things around these is what to look for. Certainly, with your different senses, sight, sound, smell, we'll look to see if there's any smoke coming from these vehicles, but we'll also look at things like the smell. We know that when these batteries are about to take off, they oftentimes give off a sweet odor like cherries. And that's one of the things that we will be spending time talking to our people about. The other thing, obviously, is protection and how to protect people. We will include that in our training. If you look to the left, we've already sent out this alert to alert facilities and alert members and others that if they're not properly trained, they shouldn't be messing around with those vehicles. However, we'll be looking at ways to protect people from electrocution by wearing arc gloves and also arc shields and arc flash protective clothing, and also rescue hooks, and having those available on site in case somebody does get into trouble with the electric side of those vehicles. We're also looking at testing equipment, being able to test if there's any potential within those vehicles, being able to test whether or not there's an issue with compromised cells within those vehicles, and that'll all be part of the training in addition to everything else. Excuse me. We're looking at basics on how vehicles function. People will not have an understanding of how to disassemble the vehicles until they have an idea of how the vehicles operate, how the different components interact with each other, as well as how to safely disconnect the components and get ready to remove things from those vehicles. I too have a shaky mouse. I'm sorry about that. The other thing is types of equipment that are going to be needing within the facilities, making sure that we have the right lifts for the vehicles and making sure we have the right lifts to remove the battery safely. We don't want to be necessarily taking batteries out with a forklift where you can compromise the battery itself. We want to make sure that we're able to take those batteries down safely and remove them from the vehicle safely. In addition to that, we're needing to talk about fire protection within our facilities and detection of what I spoke about before about off-gassing, but also having a well-ventilated facility so that we're not affecting anybody with the potential for exposure to those gases if something does go wrong. Some of the other challenges that we're facing and we're looking at is battery storage on site. Making sure that the areas where those batteries are stored are not subject to temperature extremes, particularly higher temperatures. We want to keep those batteries somewhat cool so that they can't have an issue with getting overheated and catching fire. And then speaking of fire mitigation itself. There's a lot of discussion about what to do if one of these batteries takes off. We know that in many cases, fire departments are told to bring 3,000 gallons of water to a scene with an electric vehicle. There has been some discussion whether or not it makes more sense to let the battery burn itself out because of the issues of not being able to get to the cells within the enclosed batteries, or if it makes sense to submerge the batteries in a liquid container of sodium liquid to both de-energize the battery and put the fire out. We know of cases where the fire department has come to extinguish a fire on an actively burning vehicle, only to leave and come back a few hours later because the vehicle caught fire again. So these are things that we're looking at and things that we will be training our members as they work on these vehicles. The other thing we need to be concerned with is shipping and handling. Certainly, uncompromised batteries can be palletized and shipped carefully within the regulations. But what do we do with compromised batteries? We're looking at casks to put those batteries in, and the casks will have material in there to extinguish any potential fire within that cask, and other technologies that are available that we can share with our membership in order to handle these batteries safely for recycling. There is a promise of evolving technology and safer systems. We know that the professionals and experts in the battery industry are closely looking at the current technology, and they're looking at other sciences to introduce silicone and other materials to make these batteries safer and a little more easier to work with and handle. And we're excited about that technology. And I was at a series of meetings not too long ago where they were talking about these technologies, and it's very exciting to us, not just for electric vehicle batteries, but for all batteries moving forward. So we look forward to that. And I wanted to point out that we're not the only people that are our industry that's concerned with this. The towing and recovery industry, as well as fire services industries, are concerned with how to deal with these vehicles and how to deal with these batteries. And they're learning as we are about what to do and how to handle them safely. Lastly, I wanted to talk about the hope for better vehicle design for easier and safer recycling. And not just vehicles, we look at that for all products out there. We, as I said, are in the recycling industry, and we would be excited to hear about ways that we can recycle these easier, remove batteries from products and vehicles easier. And we're hoping that the manufacturers of all these things look at this as we move forward with technology and look at easier ways to take them apart. And that's what I have for now. And I just want to say again, thank you for the time, and I appreciate it.
Okay, thank you, Jerry, for that presentation. Now we'll just move on to the second speaker. Shane, are you ready?
To talk about battery recycling? You bet.
I wanna,
Always.
I apologize for inserting myself in here, but you've noticed that the chat is disabled. You can ask questions through the question and answer function, and we'll either answer them live or within the chat if somebody is smart enough. What about silicone improves the safety of batteries? We'll just ask that one quick.
I don't, maybe the other speakers have a little more information on that, but what I can tell you and what I've learned is that the silicone will actually be used between the levels of the cells, the material within the cells, to keep the material from being able to contact each other. The batteries will still function. However, the material won't be touching other material to keep it cool and to keep it more stable.
Thanks, Jerry. That makes sense. We're ready. Good.
Okay. Can you see
Got
that?
it. Yep.
And it's full screen?
Yes.
Yep.
Yes.
Look at that. I figured it out. Thanks, guys. Well, hey, Jerry, thank you for that. That's a great presentation, kind of outlining some of the challenges that we're facing to do battery recycling right. So that's awesome that your organization is looking at the training and education and awareness, and then hopefully that will lead to, as you mentioned, kind of solutions. So I'm here to talk a little bit more about the EV battery recycling, but in a context of Serba Solutions is also a complete battery recycling company. So a little bit of the presentation will kind of talk to the fact that we're really a comprehensive solution. Kind of our heritage is in the history of kind of taking in all batteries, but obviously the EV batteries are the ones that are the batteries of the future, and so a lot of the conversations and news that you see out there is focused on that. So I just wanted to add that context a little bit from a personal standpoint to give additional context into who I am and what I do at Serba is, you know, I've been working on battery recycling for 23 years. So I jokingly tell people I went to my first EV show back in the year 2000. So pretty thin crowd back in those days. Maybe only Mark was there as well, maybe just a handful of people. But it's been pretty extraordinary to watch over the last couple years. You know, historically, the conversation around battery recycling was largely an environmental conversation. But within the last couple of years, it's really become this global supply chain conversation. So it's a really exciting time to be in our field. And that segues kind of into this screen where it's hard to pick up any kind of regular publication, let alone trade publication or industry specific periodical without seeing something about batteries. You know, and part of this is because, the movement towards electric vehicles is really, this is an interesting thing. It may sound intuitively obvious, but I don't think that it is. And that is really, any conversation about an electric vehicle is really a conversation about a battery. And any conversation about a battery is a conversation about minerals. So you have kind of three areas that are separate, but certainly linked in trying to achieve the outcome of, in this case, electric vehicles. But it's also going to be another use for these large format lithium ions are going to be energy storage. So as you look to kind of make renewable energy more diverse, energy storage is a big part of that. So I think there's an overwhelming emphasis on material criticality and domestic supply. And I'm going to, through this presentation, hopefully demonstrate where recycling is going to be a really meaningful part in addressing some of the issues out there. So the battery supply chain. So again, back to this idea of, if you're going to build an electric vehicle, you've got to have batteries to support that. If you're going to build the batteries, you've got to have the materials. And again, really at the heart of it, that's what we're doing at Serba. We're bringing in, and this model follows for certain battery chemistries, the historical battery supply chain model, which is take back the old batteries, recycle them, reuse those materials, and put them back into the new supply chain. So recycling is definitely going to have the ability to do that for the lithium ion space. This graph shows kind of the material imbalance. So depending on what periodical you're reading, Bloomberg, New Energy Finance, Circular Energy, there's a lot of groups out there that are looking really closely, and kind of the overall consensus with this is that we're going to run into a material imbalance, right? This one is showing kind of the three key battery ingredients: lithium, nickel, and cobalt. And these vary, these change. Even 6 months ago when this deck was put together, there's probably been modifications based on kind of more current market intelligence. But I think the takeaway for everyone on the call is just that. So again, we want to make the vehicles, we need the batteries, or we want to use the, in a renewable energy ESS application, we need the battery. To have the battery, we need to have the minerals. And so what this is showing is that through conventional sources, that's going to be a problem. So recycling can help fix the problem. Recycling can help close the gap in terms of getting those materials back into the battery supply chain. We can kind of do that at Cerba. We kind of take thinking about it in 3 buckets, right? Like one is the small lithium ion that have been out there for a while and that a lot of people in the solid waste field are seeing that's coming back from the consumer. The next one is the large format that are, kind of literally and figuratively coming down the road. And then as all of these plants get going, they'll make production scrap. So all of these can contribute to closing that material supply gap. So to kind of push pause on the EV conversation and just pivot back to the conversation about how Cerba looks at the battery recycling ecosystem. And what this slide really demonstrates is just that there are a lot of interdependency and cross-function in terms of where the batteries go and how you get them back. I always tell people that, collecting used batteries for recycling sounds like it shouldn't be that hard. But in 23 years of doing it, it's very hard. The logistics are very challenging. They add a lot of cost. And so as the market grows, managing how you get the batteries, what kind of batteries you're getting, and how you manage their movement are going to be key considerations. And that's why we have this map kind of showing that, and I'll talk a little bit more about this on the next slide, of kind of the history of Cerba Solutions and how kind of some of the associated companies that it's worked with really gives some unique logistical advantages. So what the pins are showing there in Ohio, in Michigan, Arizona, California, and British Columbia are actual facilities where we're either receiving batteries for sorting and or processing. The circles are facilities that we have a relationship with, a company that, either an environmental service company that's got, TSDF for 10 days. They're equipped kind of with the right drivers, the right trucks to pick up the material and get the batteries aggregated and sent to the proper facility for recycling. So a little bit about Cerba Solutions in terms of our history. A lot of folks on the call may have done business with kind of our preceding companies. So Heritage Battery Recycling was started as part of the Heritage group of companies, large privately held company in Indianapolis, a lot of very mature industries. They were looking to expand their sustainable investments footprint. And so that was kind of the reason for creating Heritage Battery Recycling. Heritage Battery Recycling then acquired Retrieve Technologies, which Retrieve Technologies had a long history of lithium ion recycling. The facility there in Lancaster, Ohio was actually built out with DOE funds that were put into the ARRA, which was the first stimulus bill back in 2009. That facility was recently awarded a $75 million expansion. So Retrieve was really good at the processing piece. The last part of Cerba is Battery Solutions, and Battery Solutions was very good at the collection and customer facing portion. So between Heritage's understanding of kind of the environmental market, Retrieve's processing, and Battery Solutions, you have a really complete service offering. So again, those facilities that you saw are taking in everything from alkaline batteries, nickel cadmium. So we're processing across the spectrum, but again, we're also doing lithium ion and have been doing lithium ion. In Trail, British Columbia, they've been doing lithium ion processing there basically since there have been lithium ion batteries to recycle. Like I said, Ohio, that facility came online in 2015. So many years under our belt, because there will be some time as the EV market ramps up. So, we think education is important. How do we dial in the most efficient collections? One of the things that we'll talk about a little bit later in the slide is how does diagnostics and testing and the possible use of the battery as an energy storage device all of these things we think are going to be key areas that will allow us to kind of grow our business while the market is ramping up. So I'll talk a little bit about the actual processing of the lithium-ion batteries. And this is really pretty much a conversation about historical versus future state. And so the historical model has been basically using really a lot of process expertise and experience, a mechanical process to kind of separate the batteries under solution, and you're kind of getting the active materials kind of coming off and going in one way, in one direction. You're getting the solid substrates being kind of held up, and so you get kind of two recyclable materials, one that has the nickel and cobalt, one that has copper and aluminum. All of those can be recovered and put back into the supply chain. The future state is with the DOE money, and we had actually announced this prior to this because we were going down the path anyway, which is adding hydrometallurgy to start taking that material and further refining it so you can pull out additional materials that will support the battery supply chain. And this is what it looks like. This is on the active material side. So this would be the part that would have the lithium, cobalt, manganese, carbon. All of those materials are infinitely recyclable back into the battery supply chain. So just to kind of, and again, I think Jerry did a really nice job of identifying some of the challenges that are out there. I think a few more that just mentioned are, the distribution. So one of our facilities has worked with the OEMs on storing new batteries in support of warranty work. So you have a portal that the dealership can order the new battery, the battery's delivered, the old battery's picked up. Diagnostics can be applied to kind of tell you about the state of health of that battery. And then based on that, you can make decisions about whether it has potential for second life or if it needs to go for recycling. So that involves kind of similar to, kind of standardized training. We have kind of developed our own internal training in terms of how you handle the batteries, what state they're in. Safety is very much at the heart of Serba Solutions culture. It's job one. It's the most important thing that we do. So all of the training and the interacting is always kind of viewed through that lens. But again, I think our experience has really created some unique education that we can then apply to the market. Again, I won't go into a lot of detail on this. I do think this is really interesting. As these vehicle batteries, years down the road, over time, lithium gets intercalated on one side of the cathode or the anode, and so over time your battery capacity fades. And so when it gets to a certain point, the OEMs don't want you to use it in a motive application, say 79%, right? But that's still pretty good capacity as a battery. So it creates kind of an interesting story about, will there be applications for batteries that can't serve in their initial function, but could very well be used in additional applications. So we're starting to look at that. We're starting to kind of understand what type of diagnostic tools we would need to scale up. But I think this is a really interesting proposition. And again, if you think about it, the mantra probably for many on this call is, reduce waste, reuse waste, then recycle. So this idea of reuse, it having kind of a more value creation is very interesting. So just to kind of recap, we believe the industry's at a tipping point. We feel like we have real solutions based on experience, and we're excited to take those experiences out and partner with everyone in the ecosystem to kind of get the batteries in, get the batteries managed properly, the ones that need recycle, get those materials back into the battery supply chain so we can continue to expand and grow. So I'll stop there. I don't know, Jennifer, did we want to do questions between myself and Mark, or do you want to roll to Mark and then we'll all stick around for Q&A after?
I would say stick around. I asked the one question because it seemed speaker specific, but we have some sort of general questions as well, and we typically hold those to the end.
Awesome.
Thank you.
Right, thank you, Shane, for that presentation. Mark, when you're ready, please.
Thank you. So
Sure.
thanks for having me. And to Jennifer, we're almost at 180 participants. It's 172. So by the end of this presentation, we'll probably hit the 180. What do you think? So I'm going to try and share my screen. And does that work?
Yes, we can see it.
You see it as a presentation?
Yes, we can. Yeah, that's fine. Perfect.
So Umicore, not many people know about Umicore because we're really a business-to-business company. We're a global company, but we are headquartered in Belgium. So the picture you see here is our battery recycling facility that we have in place since 2011 in Hoboken, Belgium. So Hoboken is a town near Antwerp, near the port of Antwerp in Belgium. I'm going to give you a quick overview of the presentation. I tend to use slides, so I'll be going quickly through the slides. But I do have an obligation to give you some background as to what Umicore is. So we're really a material company, and we have a lot of material expertise. We consider ourselves one of the largest precious metal recycling operations in the world, and we refine over 20 different metals. And the company has been around for several years, a couple of 100 years, and we have been reinvesting a lot of our gains into R&D to develop further projects. We are known to recycle end-of-life catalytic converters. So those that are in the presentation, if you have some catalytic converters, you know you can recycle those and recover the precious metals, being the platinum, rhodium, palladium, to give that a second life. And based on that technology, we have developed a battery recycling technology. Why are we talking about this? Because Umicore is a major supplier of battery materials. We don't make batteries. We supply the materials that battery manufacturers use. And this is a footprint of where we are producing the battery materials, with one exception being the battery recycling facility in Hoboken, Belgium. But our North American presence was announced earlier this year that we're going to build a battery material facility in Loyalist, Canada, which is halfway between Toronto and Montreal. So we've been, how would I say, a pioneer in the recycling process. That's why we developed a recycling process in 2004 and been operational since 2011. The technology of which has been updated last year. A quick overview of the material life cycle. I'm using a bit the cycle that Shane had put forward, but this is really focused on the materials, where on the right side, Umicore plays a role, but then there are other players on the left side. The battery cell manufacturers, the users, the end-of-life battery collectors, and that then returns to recycling to recover the different elements that make new battery materials. Closing the loop involves a lot of complex challenges, and you might have heard it from Shane's presentation. There's a whole range of things that need to happen, and not one single company will be able to resolve all the problems related to that. One big one with end-of-life electrical vehicle is the collection and logistics. And then, like Shane mentioned, determining whether second life is worthwhile or not. If there's no second life, then the battery pack will be either pre-treated, either mechanically by being shredded, or pyrometallurgically. All battery recycling processes have a hydro metallurgy that is used to refine the materials and then to make the precursor and the cathode materials. In December last year, the Canadian Standards Association put out a study, which I encourage every one of you to take a close look at. But in summary, this was the schematic that they basically came up with, where on the top left side, you have PCAM, precursor cathode material, and CAM being cathode material. It's cathode active material, actually. That then brings the cell manufacturing and then the use of the lithium-ion battery in EV. And what is of interest to us is what happens to the EV battery at end of that first life, at end of the life in the automotive application. Basically, they finally end up at the auto recycler or at the OEM or dealership. And they get to determine whether the lithium-ion battery pack has a reuse or repurpose function or not. If it's determined to have reuse value and or repurpose, then that lithium-ion battery will have a second life, be it in energy storage, be it in other battery applications. Shane is very right to point out that the functionality of a battery is a lot more valuable than the materials that are contained. But then even at the end of the second life, that lithium-ion battery can be recycled to recover the different elements, such as the nickel, cobalt, lithium, or it could be used for other applications. Some of the key gaps that were identified in that study relate to all these points. I'm not going to read them to you in detail because I think these presentations will be made available, but it just shows you that this is still a nascent industry. There's still a lot of unknowns, and the whole relationship with the second life and what to do with the end of life of the lithium-ion battery. There's still a lot of questions around it. So I'm afraid we will not be able to answer all your questions, but we'll do our best to try and answer most of them. What are the challenges affecting reuse or recycling of EV batteries? Numbers vary. Not everybody can agree on the exact numbers, but everybody agrees that the growth of EVs is going to be exponential, and then the growth of the material that is becoming available globally is going to be increasing exponentially. Where you see here the blue histogram is production waste from the battery manufacturers, and the red one is the end-of-life batteries that become available. Another item that Shane presented differently is the demand for the different elements being nickel, cobalt, lithium, just to illustrate that there's going to be big demand, but recycling can help. Recycling will not be the solution to everything, but recycling can help as we get more of these metals out of the ground. Globally, there will be different regulatory frameworks. Being based in Europe, we know best, Umicore knows best the European legislation. And this is an overview of what is in the pipeline, what is the situation today, but also what the targets are. There are even targets for recycled content. And that then is addressed towards the battery manufacturers, that by 2035, the battery manufacturers need to have 20% of their cobalt that comes from recycled material. Similarly, for nickel, 12%, for lithium, 10%. My question would be, is the US going to follow suit? Now, in any presentations, I just report what European regulations are, but I don't encourage anybody to follow suit completely, but we maybe could learn and just keep the best of that system. The difficulty being not just the size or the format difference of the EV batteries, but then the composition thereof. As you can see, there's a major variety of different cathode materials, aluminum foil, the separator. And I guess that it's the separator that was discussed earlier on by Jerry, being the silicon that might be less hazardous. There's graphite, copper foil, electrolyte. That's where the hydrogen fluoride comes from. And of course, the different containers, the casing materials that could be plastics, aluminum, or steel. The question being, if you can reuse this as a battery, you don't have to recycle this material as such. The Umicore process today can take the module size as whole, so that doesn't need to be further dismantled. And the facilities of the future will be able to take the whole pack as they are today in our recycling process. But the question really is it worthwhile to do that? Aren't there parts that can be reused? So when you're looking at the cost of making what we call an NMC 811 battery, NMC stands for nickel, manganese, cobalt. And there is a wide variety of different chemistries. So when one speaks about lithium-ion batteries, you have to differentiate between the different materials that are in it. And the chemistry that's being spoken the most about is lithium iron phosphate, or LFP, which doesn't contain any valuable material. So at the end of life, that material will also have to be recycled. But as the lithium and the iron phosphate has less value, who will be paying the bill? Good question. The closing the loop requires to make a lot of material. So it's similar to a mining plant. But really, the purity of that material needs to be similar to what is a pharmaceutical plant. So you really, when you're talking about battery cycle, you have to have both aspects of the business, the volume, but then the high purity. As mentioned, Umicore has been active in recycling, and we have a facility in Hoboken, Belgium that has been recycling end-of-life electronics since the 70s, end-of-life catalytic converters since the catalytic converters were being used. So that's why we developed the lithium-ion battery recycling. With the major industrial facility being in Hoboken, Belgium, we can process about 7,000 metric tons of material there. But we do need to dismantle the larger packs to be able to feed our process. Now, you always hear about two different technologies, pyro versus hydro. But the correct interpretation is pyro versus shredding, because all battery recycling processes have a hydro, which is the end refining, which is in green here. And there is an alternative way to either smelt the battery or shred the battery. And basically for us, for Umicore, we are doing the smelting operation, but we're taking a look at the second side of it. And that's why we have two flows. One being the pyro battery smelting, but then the other one really starting from black mass, and everything was talking about. What we are planning to do, we have in place already the facility in Hoboken, Belgium, which has 7,000 metric tons a year capacity. But then this year we're going to decide on building a larger facility, 150,000 metric tons a year, where in Europe that will be determined this year. The next step will be a facility in North America, where that probably will be determined in 24, but should be operational by 27. And basically, these are the two battery recycling processes that are out there. One with the pyro, which is Umicore, and others with shredding physical separation. But like I mentioned, that could be then generating a black mass that we then could further process. A quick overview of what track A and B involves and what are the issues, the EHS issues, the recovery yield issues. Our process was developed based on portable rechargeable batteries and mainly lithium cobalt oxide chemistries. But our process has been adapted for the electric vehicle battery packs and mainly the NMC battery chemistries. So basically, yes, there's a lot of waste or end-of-life batteries that is going to be generated in the coming years. But we will have facilities on a regional basis to process those materials. So for us, battery recycling is an opportunity, but it's also essential to be able to keep the supply chain going for the battery materials. So we are upscaling both the pyro and hydro recycling routes. And we are also using what they call life cycle analysis to determine, well, which of the processes is the best for society. And that was my presentation. Thank you.
Oh, thank you, Mark, for that presentation. Now I'm going to hand it over to Steve. Steve, are there any questions in the Q&A?
There are a couple questions.
All right.
Let's see if I can, gonna go to one generic first, and I'll open this up to any of the speakers or any of our planning panelists. One of the attendees wanted to know if EV batteries are considered a hazardous waste due to combustion, or are they universal waste? Anybody have a response?
I mean, I can take a swing at that, but with the caveat that, you know, Vice President of Strategy and Business Development. So, you know, I'm sure there's a more nuanced environmental answer out there, but just having been in this field for a long time, it's like become a personal thing, right? Universal waste is a conditional exemption, right? It's a conditional exemption of hazardous waste. I remember, you know, the two conditions are the batteries are intact and they're going for recycling. So historically, batteries had rec metals in them, lead, mercury, cadmium, right? And so the idea of creating a universal waste exemption was to facilitate recycling, right? But then technologies have kind of grown, and, you know, nickel metal hydrides came on the scene, and they really didn't have any rec metals, but it was easier just to kind of treat them as universal waste. And right, and now lithium ion, same thing, no rec metals, but are there issues with ignitability or reactivity given the state of charge? Could that create a scenario? So I think, you know, at some point getting a lot more clarity on that from the regulatory folks would be helpful. But that's kind of, as I understand the relationship, you know, the whole point of universal waste was to try and facilitate and make easier recycling. But I think it's important to understand that it in and of itself is a category that speaks to another category.
Thank you, Shane. Well answered. It's pretty much unsure right now, so.
Could I just make a comment referring to that?
Sure.
So the notion of universal waste is a typical US understanding. It's a US determination. The problem we're facing with a lot of end-of-life electric vehicle battery packs is global. It's a global issue. So we really need to go beyond the specificity of defining what universal waste is. And I agree with Shane that yeah, rechargeable batteries have been in the universal waste section, but they're not really well defined because they're so new. And the regulator is trying to determine what should and what should not happen.
Thank you, Mark. I'm going to go back to Shane with this one. The question is CERBA getting interest or support from the federal government for the second life use efforts, or, you know, what kind of support are you getting there?
Yeah, I think that, you know, broadly, I think from what I've read, it seems like, just like Mark pointed out, there is this higher valuation, right? So the idea of, you know, building a new battery or being able to use this battery that is still, you know, it wasn't built for this application, but it meets kind of all the technical parameters, is interesting. And I've read things, and including, you know, I think in the FOA that came out, I think it was 2680. That FOA actually did have some award winners in the 2L space. So CERBA didn't, you know, didn't participate, but it they did announce some winners in that sector. So I guess in a roundabout way, that's answering the question that certainly there's some degree of interest there, because they did include it in one of the funding opportunity announcements.
Okay, thanks, Shane. I'm going to give this one to Jerry. Would you say that the current level of awareness among scrap metal auto recyclers, is there a good amount of awareness, low, medium? What's your thoughts?
Unsafe handling.
Yeah, unsafe handling.
I would suggest that nobody really fully understands, and I would suggest that we're all learning, and that's one of the reasons why my last slide said designed for recycling. We create products and turn it out to the consumers, but we don't think about where the end life of those products are going to be and how we're going to deal with those products, and that's including vehicles. I had numerous conversations with manufacturers of autos, different manufacturers of autos. And when I asked the question of how do we safely work with these products at end of life, they said, well, we're not sure yet. We'll get back to you. And that's where we're at. And that's why we are developing this program, working with many, even in the auto industry, to get a good feel for how to work around these safely and securely and be careful with it. Our members are learning quickly. We always do. We always come to the table when it comes to dealing with products and figuring out what to do with them, but we're working on it.
Okay, thanks, Jerry. I'm going to throw this out to any of the speakers. The question is, newer research is showing recycled lithium batteries with cathodes that are refurbished rather than completely broken down are better than recycled like new batteries. Does this factor into anybody's plans? So it sounds like the question is about, rebuilding parts of batteries rather than generating a whole new battery. Anybody have any thoughts?
I could start, but Shane knows what I think. So basically, that is not Umicore's standpoint. I know people are trying, companies, associations are trying to develop new cathode materials from existing cathode materials. But you have to realize that the cathode materials or the batteries that are being made today have a certain chemistry. The batteries that are needed when my battery of today will reach end of life is 10, 15 years from now, they will be needing different cathode materials. We don't know yet what, but it will not be the same as today. So to try and recover today's chemistry and reuse it in another battery, there might be some applications for that, but it will not be across the board because the batteries being made in 15 years will be different.
Yeah, I think of it from a nickel and cobalt and lithium perspective, right? Like that you're getting, the pounds from somewhere, right? And if you need so many pounds, then where you get the pounds, then that starts to become a function of, certainly there's an environmental or a carbon or a logistics case where you can say lithium from, Ohio or nickel from Ohio is better than nickel from, across the sea. But in terms of technical performance, I think that's kind of an interesting thought. When you are mining, you get local variation, right, in the ore body. So recycled material, in theory, having been processed once, you may find some benefit to that it's been kind of run through the washer, if you will, once before and kind of cleaned up. So I think the recycled content is going to be a really again, it just, when you look at the materials globally, it starts to take on kind of a zero sum game. So getting recycled content in, to me, makes a lot of sense. I'm gonna have to.
Okay, thanks, guys. One last Q&A, and this is more of a answer than a question. One of our attendees presented that in California, EV batteries are considered universal waste. So we have another Q&A. The attendee says, please note the universal waste are a subset of hazardous waste, not an exemption or exclusion. Universal waste are hazardous waste, but have a different storage and handling requirements to facilitate proper collection, recycling / disposal from non-traditional waste generators. That's a good answer. And there's also factors in, you know, whether the state that you're in is an authorized state and has their own set of rules, or whether you're following federal rules. And, you know, here in Michigan, we're an authorized program, so we have some nice little quirks in our law that aren't in others' laws. So, you know, it all kind of comes down to where you're located and how you're doing the collection. So, any other questions? Jennifer, is there anything I didn't answer?
No, I think some of the general ones we can leave till the end, but I guess, you know, it doesn't really matter if we do them along the way as well.
Well,
Yeah.
But I think, well,
Thanks,
somebody
Steve.
said great job, so I guess we'll keep it up.
Amanda had a question. Amanda
Yeah.
had a question. No?
Yeah.
Yeah, well, maybe for all three of you, but so I was going to ask who's paying for the recycling, because it will help Mark to hear how it's happening when it's usually the EU's ahead of things. And then, you know, Shane, you mentioned how collection is at auto recyclers, OEMs, dealerships, like the difference on who's paying for that recycling right now.
they're silent.
Look, the kind of the model, the way the model worked historically was that you would have whatever you were recovering on this end, right? And then minus whatever it cost you to do that. So to collect, to process, right? And then on this end, you had either a credit or a charge, depending again on how much value is here. And that value varies based on what you're collecting, right? So, you know, if you're talking about mixed metal oxide, lithium ions in certain cobalt, nickel, lithium markets, could there be enough value over here that could create credit scenarios here? Yeah. If you're talking about, you know, an alkaline battery where zinc and manganese don't have as much value, right? And so to collect them and process them, you may have to pay a tipping fee here. So I think one thing I would just say that I think is important, and I talked a little bit about it, and Mark kind of talked a little bit, you know, what we've been doing for the past 22 years, it's going to be instructive to a certain extent, right, on the fundamentals, but the scale is so much bigger. Things are happening so much faster. It's in a global setting that, you know, I think they're really, we've got to be thinking about how do we adapt to this emerging market. So sorry, Amanda, I didn't want to get too far away, but I think it's an important kind of, there's a historical basis, and then, you know, supply and demand could affect that model in a way that none of us are anticipating right now.
Yeah, thank you, Shane, for that response. I know we had some other questions that came in earlier, so I'm just going to
I think
ask.
Mark was going to help for the EU side of, you know.
Oh, how did you know? How did you know? Yes. So Europe has legislation in place that the automotive producer or the company that puts the car on the market is responsible for end of life. So who pays the bill for recycling? In Europe, it will be the automotive company or the commercial company that is selling cars that are not produced in Europe. California is discussing or is going to be discussing similar legislation for California. So I'm afraid that EPR is becoming alive in the US also. Because basically having the automotive company pay for recycling is extended producer responsibility.
All right, thank you, Mark. Does any other speaker want to add to that? Any of those? Jerry, you want to add? You want to add to that? Okay. Now we had an earlier question on hybrid versus, EV batteries. Can you touch on that? I mean, how do you handle them? How do you recycle hybrid batteries versus EV batteries? Thanks.
I guess I can start on that. We look at hybrids as a little bit easier to deal with on our end because the batteries are much smaller. The potential for damage to those batteries is a lot less. And, we're not as concerned about the hybrid batteries as far as safe removal and safe handling of them as we are the full electric vehicles. And then I'll let the other gentleman.
Yeah, I think that's a great point, Jerry, about the size. The hybrid systems weren't as robust or as large. And from a historical perspective, the chemistry is different. Like nickel metal hydride was kind of the preferred chemistry, I think, prior to like 2012. I think you can have hybrids with lithium ion in them, but when you look back, it was typically nickel metal hydride, which if you look at the composition of nickel metal hydride, it's kind of nickel, cobalt, and rare earth. So if you think about lithium ion, there's nickel and cobalt, and so it's a complementary chemistry in that it has a lot of material in there that needs to come back and go into the battery supply chain.
All right, thank you. Does any of the speakers also want to add to that, or?
I just can reinforce that basically the size is different. And you have to ask yourself, what is the chemistry of the hybrid battery? I think if the chemistry is nickel metal hydride, it's a lot easier because it's a lot safer to handle. And there is an existing market out there in ferro-nickel alloys, and the nickel is being used in that. If the hybrid battery is lithium ion based, then I should revert back to the issues with EV battery packs.
Thank you, Mark. As a follow-up on that, so is there going to be like a decline in hybrid versus EVs in the future?
My understanding is there's a push to go completely EV here 2035, 2050. So I think that the push is going to be to do away with combustion engines and go with the full electric.
Okay, thank you. And also currently, like in the US, I know that Shane did try to touch on this a little bit. Always really collecting the EV batteries, like for state departments, like when a citizen calls us to say, okay, I have EV batteries, how do I get rid of it? How is that being handled in the market currently?
Yeah, I can take the first swing. I think that right now there's not that's not super defined. I think it's following the vehicle a lot of times. So we've been looking kind of across the spectrum as we do kind of with all of the collections, to where if the vehicle's reaching end of life, obviously that's something. And again, this is where I think probably a lot of Jerry's members are seeing some interaction with this, but because it is of concern, we'll see from environmental service companies, right? Kind of the automobile auction industry is starting to look at it. So I think you have a lot of people that are now starting to look at it and kind of realize we want these to be collected. We want them to be handled properly. But they're, as of today, I don't think that system is fully dialed in, which is why, we kind of take an all of the above approach to collection.
If I might, that's why I mentioned earlier that we learn by doing, and in time we will learn where we're going with this, and we're still in the infancy. What we don't want, in my opinion, is for the novice to try and take these batteries out and bring them somewhere to try and sell them. We really need to strongly urge the general public, unless they're properly trained to deal with these dangerous systems, they shouldn't be touching.
All right, thank you. And how are you getting your feedstock, and that may go to Shane, like where do you get your batteries from, like your feedstock? Like
Everywhere.
everywhere.
So, batteries are they've very quietly become this integral part of, our lives, from, everything from our smartwatch to our laptop to the cloud so they're kind of, they're all over. And so looking back at the collection, Service Solutions, we have everything from, small containers that a small business can buy, all the way through to, our own trucks where we're going out picking up full truckloads. So it really is just kind of finding the point where the battery reaches end of life, and then providing an easy and efficient way for the consumer or the business to manage that. But I think there's a lot of upside potential there. I think education and awareness are going to be important, that it's not only the right thing to do from an environmental standpoint, but it's also the smart thing to do from, creating kind of these domestic supply chains. So.
Right, thank you for that. Now there's another question about manufacturers being worried about, taking their batteries back if they've been reused and not sure what was done with them. So what are your thoughts on that? Anybody wants to? Yeah, because if I'm a manufacturer and I know what's in my battery and that's moved on to somebody else, then me taking it back. So I know there's been some fears and concerns around that. So I was hoping maybe you could shed some light on those as well.
I don't know in what case that would happen. So basically, if the battery is in a car, the car manufacturer has sold that battery, and at end of life, that battery gets reused in energy storage. It's far removed from the automotive, from the car manufacturer, so they don't see the battery coming back. Is that the question? Not sure.
Yeah, I guess you kind of touched a bit on that. Thank you. Steve, I think there's some other questions.
We got a couple.
Do you want to take that? Yeah, thank you.
Yeah, one of them, actually, it's a pretty good question. Not that any of them were bad, but it kind of broadens our perspective. Does anyone think the electrical grid will limit the growth of EV vehicles?
I'm glad that question was asked. It's something that I'm not an expert at, but I've had much discussion with it. I think the grid is challenged at this point in time, particularly in certain regions of the country. We hear about rolling brownouts, and I don't think that it's up to where it needs to be if we went full electric. I think that the grid's looking at it as well, and looking at innovative ways to make transmission better. I will suggest that 61% of the power in the US right now is still from fossil fuel. So we're still creating electricity with fossil fuels. And I'll also suggest that some of the older developments in the country, 1940s, 50s, or what have you, had certain rated wiring coming to the homes that will probably need to be increased, as well as within the homes themselves. Suggested that you need a 50 amp breaker to rapid charge a electric vehicle. A home with a 100 amp breaker panel may not be able to take care of that 50 amp breaker. You'd need to move to a 200 amp breaker panel. Those are things that I've been hearing and that I do believe.
To answer the question, if the grid stays as it is, it will definitely limit the growth of electric vehicle. If it changes, if it's adapted itself, then it might meet the requirements of the growth of electric vehicles. At the end of the day, it's anybody's guess if we're going to be driving 100% electric, or it's going to be a mix of electric vehicles, of hybrids, of combustion engine vehicles, of hydrogen-driven vehicles. So I think it's going to be more of the latter. So it's not going to be one single technology that's going to be driving. That was my personal thought.
Thanks, Mark. Got another question in the chat. Can any of the speakers talk a little bit more about the challenges associated with shipping large batteries meeting DOT standards?
I'll take a stab at it. I don't have the regulations right in front of me. I can tell you that if you're shipping batteries over a certain amount of pounds, you must be trained in DOT hazardous materials regulations in order to ship those batteries. You know, the other challenges would be, as I mentioned, compromised batteries versus batteries that are completely intact and deemed safe. There's still going to be a need for separation of those batteries within the shipping vehicles, but also looking at specific separation for potentially compromised batteries.
All right. I've not been looking at the chat. Is anything new in the chat, Rachel?
Yes, Sarah was asking about the challenges associated with shipping large batteries. Okay, did we just answer that one?
I don't think we did.
Yeah, we did, but it's
Okay, yeah.
going to be a challenge.
Yeah. Then there's another one from Larry about how to get rid of a Ford alkaline EV battery. Does anyone have an idea?
I do.
Okay.
I'm not 100% sure about alkaline, but I just wanted to let you know, Larry, that we've gotten a couple of EV battery drop-offs at HHW. It's not something we expect to handle at all. So I think it's do-it-yourselfers, probably watched a YouTube video. But we did get what we recognized, we as in Hennepin County did get a battery they recognized as a Toyota battery. And they contacted Toyota and it wasn't simple, but Toyota took it back. So if it's, I would contact the manufacturer and tell them to come and get it, see what luck you have. Oh, Mark's nodding. It's a maybe.
That's a good idea. Good idea. Let the producer take it back.
Yeah, I'm sure Mark is definitely pushing for that. Well, thank you, Jennifer, for that. And to all our speakers, do you have any last words? I'm pretty sure there's some opportunities that you've seen out there or that you're seeing that you feel should be a part of this. So this is that moment if you want to just say one or two words about that.
Yeah, a lot of, Jennifer and I have worked together in different capacities on battery recycling over the years. And, I certainly am appreciative and not sure of, kind of who all the participants are, but if there's a lot of, local HHWs and folks, we're happy to be a resource at Service Solutions to kind of help you through, whatever issues you're having, whether it's battery identification, packaging, performance packaging for safety. Always happy to share in kind of that desire to educate and advocate for battery recycling. And then again, position ourselves so that, as these large format batteries start coming offline, we've got a system in place where those materials find their way back into the battery supply chain. So thankful for the opportunity to share the stage with my esteemed colleagues.
Thank you, Jerry. Mark?
Always a pleasure, Shane. I think the nascent EV battery industry is full of opportunities. We need people that are active in collection. We need people that are trained to handle high voltage materials, and we don't have that today. So I think that there's a room of opportunities for new companies, mom and pop shops, to come up and to start participating in this supply chain. Because what we know, it's important that these materials do not end up in the wrong hands, and that we're able to recover the metals to make new battery materials.
Thank you, Mark. Jerry, any last words?
The recycling industry is up for the challenge and we're working hard on it. And just want to say thank you to everybody for allowing us to speak.
Yeah.
Well, we
Guess
just
what?
wanted
I have
to
a new
say-
question.
Okay.
There are a lot of there's a lot of money available from Department of Energy to build up the infrastructure for processing and that sort of thing, but there was $0 given for collection. And I wondered if any of you that have received those monies or have talked with DOE, if you see any options there. I'm looking at my HHW facilities from a safety perspective, and I've come up with that they all really need storage, and we're looking at like maybe 10 or more thousand per facility. We're of course not getting paid for these batteries. We're lucky if we can get them, get the cost covered, but I'm really disappointed that it's like, okay, here's all the recycling technology, but why are the collectors being left out? It makes no sense to me because we really need help. Mark said mom and pop. Oh, no, not mom and pop. Every guy with a truck is what we usually get here. Like when we banned fluorescent lighting, everybody thought they could manage that. But yeah, we have to encourage more collections, and it's super dangerous. My programs are already talking about not taking the greater than 300 watt-hour batteries because they just can't do it safely. And there's no other option. I've been talking with Serba and Call to Recycle about it, and there's just really not an option. So I'm really concerned about that part.
Jennifer, didn't the Department of Energy have a battery recycling prize program going that included collection? That was prior to the monies being offered by the Biden administration.
If it did, it wasn't at the size where like a household hazardous waste facility could apply for $15,000 to increase their safety level, that kind of thing. You know, and your grants are huge. Your Department of Energy grants are huge that are coming out. I just need $500,000.
I think, Jennifer, let me offline, I'll email it to you and then you can send it out to the group, but I'm pretty sure the DOE does have a request for information on a funding. So I don't think it's at the FOA level yet, but it seems like they're gathering information, and that, if memory serves, was around collections. So let me see if I can get you more detail on that. Sure.
EPA did an earlier RFI. There's a lot about collection in that one, not so much in Department of Energy's. And I did work on answering both of those. But I have not looked in detail at the grant for a long time. So I don't know if there's a little niche thing in there I missed.
Yeah, I'll check and get you intel on that.
Appreciate that,
but
Shane.
I think that's the case. Yep.
Okay, cool.
All right, thank you, Jennifer. We're right about, then we only have about 2 minutes left. Again, the webinars and presentations are going to be available. Feel free to go back and look at the previous ones as well. And there's another one coming up. Yeah, we have the last webinar scheduled for next month, sometimes on extended producer responsibility. We would like to see you again, like we saw you in this one. Thank you to all our speakers. Thank you to Namar. Thank you to Nsak. Thank you to Jennifer, to all the organizers. And yeah, we hope that you enjoy the rest of your day.
Thank
Jennifer?
you.
You.
Thanks,
you.
everyone.